today's lesson, we're going to have a little look at an introduction to area. Now, area is a measure of how much space a shape or object covers. Area is always measured in units squared, so millimetre squared, centimetre squared, metre squared, etc. So once you see a measurement given with the small 2 there, power of 2 or indice of 2, you need to think straight away, this is a measure of area. This is telling me how much space is inside the object. So there's 2 shapes or objects on the board, number 1 and number 2. So area is a measure of space inside the shape. So you can see, looking at those 2 shapes, shape 1 or object 1 has a much greater area than object 2 because it covers a greater part of the board. Now, on the screen in front of you, there are 2 shapes, shape A and shape B. I've coloured the area of shape A in yellow and the area of shape B in blue. Now, if you could have a little look at those 2 shapes for me, please, and think about which one do you think has the largest area? Now, some of you might have gone for shape A, some of you might have gone for shape B. Either of those are feasible because there doesn't look like a great deal of difference between them. It's quite hard to tell looking at those 2 shapes which has got the greatest area. So we need to have some way of measuring area. And to do that, we count the number of squares which fit inside the shape. The size of the squares we use depend on the size of the shape. With small shapes like the ones we've just seen, we could use squares with sides 1 centimetre. So 1 centimetre horizontal distance, 1 centimetre vertical distance. Now, the sort of area we're talking about here is your thumbnail. Your thumbnail is roughly about 1 centimetre by 1 centimetre. We call these centimetre squares, or cm squared for short. Each square covers an area of 1 centimetre squared. Now, those shapes we were considering, which was larger, I've drawn them now onto a grid, and I'd like you to assume that each of these squares is a 1 centimetre by 1 centimetre square. Okay, so each of those squares 1 centimetre by 1 centimetre. We're comparing the area, so we want to see which has got the greatest space inside the object. And we can do that, as we just read, by counting the squares inside the shape. So here we go, I'm going to count the squares inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So shape A is made up of 12 squares. So that has an area of 12 centimetres squared, because each of the squares inside measure 1 centimetre by 1 centimetre. We're going to do the same now with shape B, so we can have a look at which is the bigger. So again, counting the squares inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So shape B has 11 squares inside its perimeter. So the area of shape B is going to be 11 centimetres squared. So think back to your prediction earlier on, which one had the largest area. We can now conclude accurately that shape A has the largest area, because 12 centimetres squared is greater than 11 centimetres squared. But it was close, so anybody who did predict it was going to be shape B, right, there wasn't a great deal in it, so I totally understand why you could have gone for it. So shape A has the largest area. The largest number of squares fit inside shape A as opposed to shape B. Okay, so let's have a little practice. So finding the area of these shapes. So we want to find out now how many squares are inside each of these shapes, because again we are assuming that it's been drawn on centimetre squared paper. So every one of these squares measures 1 centimetre by 1 centimetre. Counting the squares inside the first one then. 1, 2, 3, 4, 5, 6. That's 6 whole squares. So the area of the first shape would be 6 centimetres squared. Moving on to the second shape, you might have noticed that we've got half a square included inside this shape here. So half a square would just represent half a centimetre squared in terms of the area. Counting the whole squares first of all then, we've got 1, 2, 3 and that extra half a square here. So the area of this shape would be 3.5 or 3.5, I know some of you would prefer, centimetres squared. And the last shape on this slide then, we've got a few more half squares here. I'm going to count the whole squares to begin. 1, 2, 3, 4, 5, 6. And then I can say that I've got, if I count up my half squares, I've got 1 half square, and another, and another, and another, and finally the last one here. So the area of this shape here, 6 whole squares, then I've got the 2 half squares here, which would make 1 whole one. 2 halves give you a whole. So I've got 6 plus the 2 halves there is 7. I've got another 2 halves here and here. So that takes me up to 8 whole squares and the extra half square here. So in total, the area of this shape would be 8.5 centimetres squared. That's made up of 6 whole squares and 5 half squares and 5 half squares is equal to 2.5 centimetres squared. So to find the area of the shape, the space inside the shape, we need to count up how many squares fit inside the shape. To measure the area of larger shapes, we would need to use squares that are based on a different unit. When measuring the area of a large shape, like a tennis court or a school playground, we use squares with size 1 metre. So each of the squares would be 1 metre long and 1 metre tall. You're talking here roughly the size of the area covered by half the door. So think about the door into the classroom. If we were to chop that horizontally across the middle and we take the top or the bottom half, that represents roughly 1 metre squared. You aren't going to use your thumbnail, think about it, centimetres squared, you're not going to use your thumbnail to count the area of the tennis court or the school playground, right? It's far too small, so we use larger squares. So if we've got squares that measure 1 metre by 1 metre, we would call these metre squared, and that is how we show the notation, m squared, 1 metre squared. Now, you need to appreciate that I've got a diagram on the board of the tennis courts. In real life, the actual tennis courts would be much bigger than this. They wouldn't possibly be able to fit on my board. So this is only a diagram, scaled down version. But what you've got to see is on the right-hand side, I've drawn it or superimposed it onto metre squared. Now, if we were to count up the number of squares I've got on this diagram, it is 264 squares. 264 squares in total covered. Now, every one of those squares measures 1 metre by 1 metre. So every one square has a total area of 1 metre squared. So the area of my tennis courts would be equal to 264 metres squared. So just to summarise, area is the space inside the shape, or the space that the shape covers, and one way to work out the area is to count how many squares fit inside the shape. And that's the end of today's lesson.